Hey everyone, my name is Jiayu. Today I'm here to present our power constraint bandit work collaborating with Emma Ponskill, Wei Pan, Susan Murphy, and Flavio Chivalas. Mobile health applications are gaining more popularity nowadays. For context, let's imagine we develop an app that encourages users to do more physical activities by sending them messages. To keep users' retention and engagement, we personalize the messages so that the intervention can be delivered at a good time. For example, some people may not like being bothered during work. We define the gap between the actual amount of physical activity and the possible maximum amount as regret. In addition to personalization, as scientists, we also want to know if our app actually increases versus physical activity. Therefore, at each decision point, we choose whether to deliver the message or not with a fixed probability. We then collect the data to rigorously quantify the effectiveness of our app. The probability of detecting effect is known as power in statistical literature. Currently, there are lots of works either minimizes regret, which requires strict assumptions for fast personalization, or rigorously determine effect under challenging settings, where the user might have less engagement over time or less motivation during the weekend. In this work, we're interested in combining the efforts of the two. We design algorithms which maximize personalization and guarantee to detect a certain amount of treatment effects at the same time. Let's first recall our definitions of regret and power, which are shown as follows. Our first main theorem states that, in a very general setting, we're able to calculate the value from the collected data, which guarantees the desired power. Then with this value, we show that the experiment can be sufficiently powered by simply bounding the intervention probability of each trial into some range, which can be calculated with a set of predefined parameters. Now that the power constraint is met, you may ask what about regret? Because our intervention probabilities are constrained into some range, our goal now is to compare to an oracle who has the same constraints as we do. For some specific algorithms, the regret rates can be preserved by simply clipping the intervention probability into the range. We also provide tools that allow the developer to take any of their favorite algorithms and make slight modifications such that the algorithm both guarantees the power and preserves good regret rates. On a realistic mobile simulator that mimics our app, we demonstrate that our approaches guarantee sufficient power, give regrets converging as expected with respect to clipped oracle, and a robust various model with specifications which can possibly appear in clinical studies. Thank you for listening, and we look forward to seeing you all at the poster session.